Well, welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. I'm your host, Richard Rastusha, and today we're going to be back to some real irrigation basics. And in this case, we're going to be talking about you're spending money on an irrigation system. There is some basic maintenance that we have to provide these irrigation systems to make sure we get the length and use out of them that we want and that we paid for. And like anything, there are some simple design specifics that you can add to your irrigation design to make it last longer, to make maintenance easier. And today we've got Corey Broad as our guest to step us through this. Now, if you've seen Corey's videos on flushing irrigation systems, you know they're top notch. In fact, even the professors at Cal Poly were telling me how great those were. So Corey is back to tell us today a little bit about what your designer or what you should yourself be designing in your irrigation to make the maintenance easier. Now, Corey, if you don't know Corey, he's a territory sales manager and product manager at Jane Irrigation, but he's so much more than that. Thing I really appreciate about Corey is his passion for agriculture. He's a certified crop advisor. He's a certified irrigation designer, and he's a certified ag irrigation specialist. He was the agriculturist of the year for the County of Madera a few years ago. He is not just committed to irrigation, he is committed to all parts of agriculture. So I'm really excited to have Corey here. And most importantly about Corey is his passion to help his customers to be more successful in their ventures. So Corey, welcome. Thanks for joining us today.
Well, thank you, Richard. And as always, thank you for the kind words. And it's a topic, like you said, that seems very basic, but definitely has some nuance in it. And I felt like it's important to bring it up because, as you can see in the photo there, perhaps my best side, the reality is I do the same. I'm asking you to do the same things that I have to do as a water manager and as somebody who manages irrigation systems for customers as a part of our offering here at Jane. I'm asking and giving tips and ideas for things that I've learned, and then also things that I have to do on a regular basis or have folks do on the ranch. And so, again, anything we can do to make it easier. My biggest thing recently is I just had my oil changed on my new pickup for the first time. And, you know, the way I thought about it is sometimes it's easier just to have somebody else do it. Yeah. But that's because they've become so complex in order to do even the most routine things. And so if you have something built where you have to take the engine out in order to change the oil, it's not a terribly efficient model at that point. And, you know, when we put these systems into the ground, we're usually stuck with them. I use that loosely for 20 to 25 years. And so we want to make sure that, again, it's easy to operate and then also easy to maintain.
Yeah, it's a very good point, right? It's not very sustainable if you have to take that engine out, right? So yeah, it's all in the design, which you're going to be talking about. But before we go there, I have one quick question for you. You know, I always think I know what the popular webinars are going to be, and oftentimes I'm wrong. I'll just admit that right now. And I wouldn't say I thought your how to flush an irrigation system was going to be unpopular. I thought it would be kind of moderate, you know, to above the halfway point. You know, it was really, you know, these how-tos are important, but there's not everybody's looking for this. And it's become super popular, you know, one of our best. Were you surprised at that?
I mean, I think that when I talk to growers and end users regularly, very rarely do they ask me about mesh filtration or per throw of a sprinkler or things along those lines. It tends to be, I'm having this issue, or I'm having this challenge, or I don't want to have this issue. Yeah. What should I be doing? How can I do it better? And I think that when it really comes down to what we offer as a company, it's that expertise, it's that intellectual property, if you will. Really, it's not as much as, yes, we have great products, but it's really about, again, being able to dial that in. I think, you've heard me say on the webinars before, I can build you a really efficient car, but if you drive it with the parking brake on, it's not going to be very efficient. And so it's our responsibility, I think, as leaders in the industry to take the next step and offer that advice, offer that insight, and not just because that's just what the textbook says, but also because, again, we're out in the field doing it also. And I think that that's what we're uniquely positioned to do it.
Yeah, great points, Corey. Thank you. Appreciate you sharing that. So anyway, I'm anxious to get into the irrigation designs and products for flushing.
Yes, sir. So again, we all know that flushing is a critical step. This is part of the introduction. This is part of the basics, as Richard, you mentioned earlier. It's a critical step in irrigation maintenance, but it's also important in the irrigation installation process. Again, many of the dealers do a great job of going through and flushing out the irrigation system through its different phases of installation, because there's chunks of glue that come out, PVC shavings, dirt that gets in, rocks, you name it, it'll probably find its way into your piping system. And so obviously getting that done at the beginning is super important. So again, it's really from even as the irrigation system is literally being installed, flushing is part of what we have to do. Degradation of the system in its uniformity and efficiency, or DU. We all know the challenges with that. And obviously with proper flushing protocols and procedures, you can mitigate that degradation. You can't stop it. It's really challenging to do that. But let's again continue to change that oil, if you will, as often as possible, and help that engine run as long and as efficiently as possible. As you can see, the emitter on the left-hand side wasn't really given much of a chance to perform its life. And this is just a result of a system that A, just needs a good flush, and then B, maybe even if it was being flushed before that, it just wasn't being done maybe frequently enough, long enough, or with enough velocity, which is a big part of what we'll discuss today. And through my experiences in working with irrigation systems, troubleshooting fields, and then even working with growers at the front end of system design, is a lot of the irrigation systems being installed are not really being designed with flushing in mind. It's being designed with construction and even just operational efficiency. But again, not thinking about, well, how will somebody have to maintain this, or what's the easiest way to do so? And again, that goes into this user-friendly topic where, again, make it easy for yourself, make it easy for your employees, and it's more likely to get done, and it's more likely to get done properly and effectively. And so that's really kind of what we want to build on today.
So Corey, I have a question and a comment. The question is this: when seeing an emitter that clogged, right? And I'm not really seeing that the emitter is clogged, but I just see a lot of dirt there, a lot of soil there in the line. Would a proper flushing actually clear that out?
You would be surprised at how robust the technology is in our industry and in the products that are being made, that you could most likely salvage this product with proper flushing procedures. The question becomes, is it gets to this point, how much uniformity did you sacrifice before that flush happens?
Right.
What was your downtime? Is that 1 out of every 10 emitters on a tree? And so you start thinking about the correlation between DU and yield, and how much I pay for water, and I'm already paying to run that pump, so I'm not getting maximum efficiency out of that. And you start adding it up on the business end, and the numbers spin in your head a little bit, and it seems small, but yeah, fixing the device, yeah, we could probably do that pretty easy. We could even just replace the device, which has a pretty well-known cost. What did we sacrifice in missing that opportunity?
Yeah, interesting. Very good. So that was my question. My comment is this: I've got the Q&A open. I've got the chat open. Any of our viewers have questions or want to make comments, please drop them in there, and I'll ask Corey when appropriate.
So when we look at laterals, thinking of emitter line, tubing, drip tape, they all have I'll say a specific requirement that needs to be met to ensure that proper flushing has occurred. Kind of the few points that I talked about earlier: velocity, duration, and frequency. Those are kind of our big 3. Velocity is really the key factor in determining how well the irrigation system is being flushed. And that's because without that factor being dialed in appropriately, it affects duration, because if you're not flushing it, I'll say hard enough or fast enough, then it's going to take longer in order to clear that line. And then also how the efficacy of that flush, if you will also probably play into your frequency too. There's some loose correlation, but velocity and duration definitely have a direct correlation between the two. So really what I think most people need to know is that laterals should be flushed at 1.5 to 2 feet per second velocity to properly remove debris from the lines. And kind of a rule of thumb that I would say most people go with is 60% of your debris is in the first 40% of your irrigation lateral. So from the riser towards the end of the hose, and 60% of your problem is in the first 40% of that line. So when we open up the end of the line and we see a little bit of dirt come out, and then it runs clear, and then a little air comes out, and then a little dirt, and it just kind of, and all of a sudden it runs clear, and you've done this for 30 seconds to a minute, well, odds are it's probably most of your material is still, I'll say, upstream of that point, hasn't come out. And maybe you've actually only just moved it farther down the hose and made more room for more stuff to fall in at the front end of it.
Yeah, so interesting. Do you just use kind of experience and feel to know that you're putting out 2 feet per second, or do you know it from the design? How do you know this?
Yeah, great point. We'll go into a little bit more on the technical side where you can really kind of dial this in. I would say that your irrigation dealer or designer should have this set up for you, or should be able to say, Richard, I need you to flush this many lines at this pressure in order to achieve what I'm looking for. There definitely are some other guides. I think even CIT at Fresno State has done some things where, if you hold the hose flat and you can kind of, if it shoots out this many feet or this many inches, that's roughly, going to be this velocity. There's definitely some references on there. I think like anything else, as long as it's not shooting out like a fire hose, but it's also not, maybe dribbling out like an oil leak. Probably somewhere in the middle is definitely a good start, but there definitely are some resources that we'll show you from the Jane website to help you kind of dial that in.
Okay, great. And then if I can't flush at the minimum, 1.5 feet per second, am I stuck?
Yes and no. It definitely depends. I would say that where there's a will, there's always a way. It could be, adding a couple products into the field, maybe some minor changes, but we'll go into some examples of what you can do within your, I'll say, quick fix methods in order to help you try and achieve that. But to your point, doing it right ahead of time will be significantly less expensive and troublesome, because if I have to come back and dig it up to put a valve in when I was already there, you can imagine what that cost might be like.
Right. Okay, great. Thank you.
So when I talk about some of the resources and options, this is on our website. It's available right now. It's free for anyone to use. This is our called a length of run calculator, but it also has a flushing mechanism in it. And so it's very easy to use. If anybody does get stuck on it and has questions, you can always reach out to us. But I would say it's pretty plug and play, user friendly. And so hopefully you can see my cursor here, but these are all just drop down menus. So in this case, I chose our Amnon emitter line, and I chose an 18 millimeter product, which has an inside diameter of 0.620 inches. I chose a 30-inch emitter spacing, and I chose a 0.53 gallon per hour flow rate. Very standard for what we would do here in the Central Valley, really common in almonds, pistachios, and depending on vineyard spacing, even that market as well. And then I went through and I put 20 pounds of pressure in at my riser. I didn't add any slope because it's Fresno and everything's flat. And I chose, 330 foot run length, and we'll go into a little bit more about why I did that. I hit the calculate button, and now it says that I lost about 1 pound of pressure because I started with 20 and I, just under 19 pounds of pressure. My average flow rate was my target of 0.53 gallon per hour per emitter. Does some other conversions for you in metric, but it says that entire length of tubing with this flow rate and that many emitters is going to be 1.17 gallons per minute during normal irrigation. Its uniformity is going to be 97%, which is just the variability among the emitters. So again, really strong to start, especially with a pressure compensating product. And with all of this information, this is all great. But if you go down and you select flushing velocity, and our two options are 1.5 and 2 feet per second, conveniently, because I want it to be kind of in that range. And I enter in my flushing length, which is going to be the length of the lateral, 330 feet. I need 10 pounds of pressure roughly at the riser when the hose end is open in order to achieve 1.5 feet per second velocity through that hose. It does that math for you. So now, Richard, you don't even have to know much else other than maybe having a pressure gauge and going out and say that you have, just for the sake of this example, 10 rows. And if you go and you open up 5 of them and you don't have 10 pounds of pressure, well, then maybe you can open up 2, or maybe it's 4. You can start to dial that in, and then you learn, oh, I can open up 3 rows at a time. And in order to flush at that velocity, because I still have 10 PSI at the head end. So you know that now you can flush 3 rows at a time. So again, these resources are still here to kind of back your way into it, but a lot of this should be available from your design at the beginning.
Yeah, this run length calculator was made for me, right? You could tell from my questions on the prior slide, how am I going to figure this out? Well, you just made it easy for me, Corey. Thank you.
No, that again, this is part of as a company, right? The resources that we dedicate and the questions that you and I get asked from our end users and even some of our suppliers and dealers is, what should we be doing? How should we be doing it? And so I think, again, it's just another resource to help you kind of dial it in as an end user, but even dealers that can use this also and put it in their irrigation designs. So we're going to get into a little bit more jargon here. So we're kind of stepping off the basic platform, as you referenced earlier, Richard, and now we're going to get into some of the technical stuff. So bear with me, but we're going to use the same example as earlier. And we're going to have our Amnon 18 millimeter. It's a 1/2 gallon emitter every 30 inches. And we have 330 foot lateral length runs or hose runs. So from the riser on the manifold to the end of the row is 330 feet. And we talked about losing 1.2 pounds of PSI during irrigation. And our flow rate through that was 1.17 gallons per minute during normal operation. And we said that we needed just under 10 PSI to get our 1.5 feet per second flushing velocity. So if you go through and you see a 620 inside diameter, like we talked about on 18 millimeter, the volume of water required to get 1.5 feet per second velocity inside that diameter is 1.4 gallons per minute. That's higher than that 1.17 during normal irrigation. And you'll see why this starts to add up and become significant. Because every riser, it's double line drip on almonds, has 4 laterals on it. You now have 5.6 gallons per minute going through that riser if you're flushing all 4 hose ends at once. If you go down to the next one, you'll see that 1.17 gallons per minute, if you're flushing all 4 lines there, that's 4.68. If you flush all 4 at once versus normal irrigation, it's a 16.5% increase in flow demand in order to achieve your 1.5 feet per second. So that's important because the riser would have to be sized for this if you were going to do it. And then the pump capacity has to be there in order to provide that.
And again, you're just taking in the 1, 2, 4th bullet, 1.4 gallons per minute and multiplying out by how many laterals you're opening up at one time.
Exactly. So kind of looking at what an irrigation design might look like, and this is just a rough layout from a field that I did using PowerPoint, but I'll walk everybody through it. So up in this top right-hand corner is kind of where our pumping station would be in our filtration unit. And this blue line would represent our main line and our submains. And then these green lines would be these manifolds that I talk about with the risers located on them. So a saddle on the pipe underground coming up to grade, and then all of our fittings connected to our Amnon emitter line. And then those purple lines that I drew going each way, those would be our laterals, those drip lines that I'm talking about. And then the red line in the middle is what we call a hose break. So instead of having these hoses connected together, we cut them here in order to get our 330 foot run length. Because this is a 1/4 mile run divided by 4, 1, 2, 3, and 4. You can see where we would end up with those numbers. And so in this example, it's 20 acres on almonds, 22 by 16, double line drip. Our normal operation for irrigation is 280 gallons a minute. When we talked about that 1.4 gallons per minute on flushing, if I add that up on every single lateral, I now have a requirement of 336 gallons per minute to flush at one time. So my pump would have to be able to go from running at 280 gallons a minute to 336. As you can see, for a lack of terminology, I said it's not going to happen because unless you have a variable speed pump, and that again was part of the design process going forward, you probably won't be able to achieve that. There's still a lot of, I'll say, fixed speed pumps out in the industry at this point. And so again, maybe a VFD would be a good investment in this case to allow you to do it. But in this example, we're going to pretend that we don't have one because again, not everybody will. So you're asking, what can I do now? How can I make this work if I can't open up everything at once? If you went through and you had to flush every single, this worst case scenario, every single line hose end individually, you'd have to flush each one for roughly 3.6, so just say 3.5 minutes. Because it's 330 feet and I'm flushing it at 1.5 feet per second, the math tells me that it's 3.5 minutes per line. Well, in this 20-acre block with 2 manifolds, there'd be 240 lateral ends.
Wow.
Times 3.5 minutes. Roughly 14.5 hours.
Yeah.
The reality is nobody's going to do that. I don't expect anybody to do that, but I'm just illustrating if you use the raw math and you were stuck in that scenario, that's what it would take in order to properly flush. But to the example earlier, let's say that we can do 5 row ends at a time or 10 lateral ends for that matter, because it's double line, right? It's 2 lines per row. So if I say, Richard, you can go down to each of these bubbles and you can open up 5 rows worth of tubing ends at a time, which in this case is 10 laterals, and you went through and applied the same math, it's still going to take you about an hour and a half of just flushing time in order to achieve that. I'm not including going to that spot, opening it, and then closing it and going to the next spot. That's just on flushing time alone.
So, well, I'll tell you what, 1.5 hours is a lot better than 14. That is for sure.
Definitely a good start.
And again, this isn't just one time difference. This is for every time that you're flushing, once a month or whatever it's going to be for the entire life of the system. So this is a huge time saver.
And this is where the payback starts to come. And I think where the light switch starts to turn on and folks go, okay, this is where I think I can justify this expense. So you talk about what can I do? Well, here's a simple change, and it's not Pac-Man, I promise. I just use this to kind of denote a valve that can maybe open and close. But what if you went and you put a valve at the head end of each manifold? You can now isolate this field into, in this case, 5-acre zones. We use zones in the landscape business quite a bit. And I mean, I have a house with 6 zones. So if I can have valves there, we can have valves out in this field. And I'll show you some of the benefits of doing it. But now I can isolate this field. Now I can close 3 of these 4 valves, just say for this one instance, and isolate 5 acres at a time. And now maybe I can go through and I can open up 60 lateral ends because I'm forcing it all into one quarter of the field. And kind of going down this and closing these 2 valves and then this 3rd valve, this time to open up the lateral ends, it doesn't matter because that still exists in the other examples as well. Those are net even, they weigh out. So, but now I'm flushing 5 acres in 3.5 minutes.
So Corey, we've got a question coming in from one of the viewers, and the question is this: those valves that you're adding, are they like manual ball valves or do they have to be something else?
They can be both, and I'll show you the benefits.
Okay.
Great question though. But illustrating that we can get down to zones, I think is what I want most people to take away, because that is again, talking about adding in a little bit of cost up front. I think it pays for itself, as you alluded to earlier, pretty quickly. So if you choose to add a hydraulic valve, which is something that we sell here at Jane Irrigation with our Raphael line of valves, you can maybe even increase the uniformity of that irrigation system because you could put either just a standard open, close, or on-off valve, or you could do a pressure reducing valve. So you can dial in your pressure if you have maybe sprinklers or another non-compensating device. Or you can have a solenoid on these valves. And even if it's just a standard off on, now when you think about automation and we think about farms of the future and what we're going to be doing, now you can open and close valves if you have multiple sets automatically from your phone. And that valve already exists and it's already there to be controlled during this flushing time anyways, where you can just turn the little selector on the top of it and just make it a manual valve if you want. But the point being is the infrastructure is there. I have a grower who told me on a very large scale project, I wish I would have thought about this because the cost to go to automation now is going to be significantly more. I didn't think about it 8 years ago when I put in this block, but now to go back through and make that change, he's kicking himself a little bit. So again,
but he's still doing it
because it's going to have to 100%. But the reality is that you plan out these costs and your dealer should be able to work through these things with you. And most of them do a good job of doing so. But even if you don't use a hydraulic valve, you could use a butterfly valve or a gate valve. Ball valves are never really recommended. The reason being is a lot of operation on them, especially being plastic. You can imagine how that might wear out over time. And then also if sand and debris get stuck in the side of the valve because of the way that it pivots, they tend to get locked up, jammed. And then that's when you take a pipe wrench to it and then nothing good happens because it's plastic. So
that's when the fun begins.
Yeah, so I've heard. I've never done it. So again, you can see very quickly where we just made some very minor changes up front, maybe added a few $1,000s. And yes, I know things are expensive right now, but amortize that over a 20-year investment and $25 an hour labor and fuel costs and energy costs. I think that the net benefit is there pretty quickly. And then talking about some other products, this was a shot from a field that I did probably 2 years ago where I had to visit, and they told me that they had flushed a couple of days before. I don't really believe that. But the point being is even if they did, at least having a ball valve on the end of this tape line would help, because you're talking about having a line of drip tape or thin wall emitter line in this case, every 5 feet instead of every 22 feet in an almond orchard. So there'd be a lot of hose ends to flush. And so this is an example of an NBV09, which is made for our tape products. We have them in different sizes. You can get them in the plastic end flush at the top end there, which is for our Power Lock series fittings. So for your tubing and emitter line in your orchards or vineyards. Another product that I see folks gravitating towards, just also from a cost perspective, is the end LSC that you can see there. And it's a tape fitting that it slides on the end of 5/8 or 7/8 strip tape, but it has a 3/4 inch cap on the end. So rather than maybe paying for the valve or talking about where maybe things get broken or ran over, this is about half the cost. And again, it's something that you can still kind of use that cap to seal it, but it's easy just to unthread and let that tape flush out. And then another product that I tend to see in the landscape market more that I know that you sell, Richard, on your side, is the kind of manual automatic flush type scenario. It's this little nozzle one that's up there, and it just has a little spring-loaded purge valve in it, and allows some of the debris to flow out while the system pressurizes. And then like an air vent, it seals once pressure increases. And so it kind of automatically flushes a little bit, but it doesn't substitute a good, strong flush, if you will, but definitely helps in the landscape market where things maybe run a little bit more often, shorter runs, those kind of scenarios. So these are just products that I see, products that we sell that can help, again, make the lateral end flushing easier.
Yeah, great points, Corey. And yeah, too often we see the end of the line just folded over and something wrapped around it. Boy, this makes a big difference in the maintenance, and as well the time it takes to flush. And those automatic flash valves I think work really well.
100%.
Yeah.
So I showed you a 20-acre system earlier with 2 manifolds in it, but I kind of want to show you some of the things that I see also. And this is where you start to get, handcuffed a little bit. And this is basically a single manifold system with 660 foot hose runs, which is again very doable based on pressure compensating emitters, good hydrology. This is all totally doable. But this is really designed to kind of take and mitigate upfront construction costs, because I have half as many risers, saddles, fittings, gluing points. Maybe my piping's a little bit bigger and my tubing has to be a little bit bigger, but you can, take out the trenching and some of these other factors, and it ends up, again, being more cost effective on the front end from an installation standpoint. But again, as I talked about, the long-term operating expenses with labor and energy is going to increase that cost more. And so again, a single manifold layout with no valves at all might be, I'll say, worst case scenario. There might be one other way that I could break this down that would be bad. But the point being is if this is the case, Richard, and you don't have anything and you don't have the pressure to flush it, there's not much I can do when I come out to your field other than hope that you have the mini ball valves on your riser, and then you can go turn off half your risers in your field every time. I've had to do that with some people even this season because again, it wasn't designed with this flushing efficiency in mind. And they kind of looked at me like, wait, I got to go turn off on every row. And I was like, yep. Yeah. I don't have an easier way for you unless you want to, have somebody dig it up and then you can install valves, and then at least you can shut off, half the field with a valve. But these are they seem really simple things, but they do get overlooked sometimes for the sake of cost.
Right. Valued engineered is a term that comes to mind on this. And yeah, the upfront cost is going to be much lower, but oh my gosh, the time you're going to put into that.
Exactly. So just kind of breaking down this example again, using the length of run calculator, I stayed with the Amnon, but I had to go to a 20 millimeter offering, so a larger inside diameter. I stayed with the half gallon, 30-inch spacing, and I'm just using the 20 pounds at the riser example. Most designers shoot for under 5 pounds of hose loss from the riser to the end of the lateral. So in this case, we had to use 20 millimeter, and we burn almost 4 pounds of pressure in that, which again is pretty common and acceptable. Still have our half gallon an hour flow rates. Our lateral flow is twice that amount because we went from 660 feet to or 330 to 660, excuse me. Still good uniformity because we're using pressure compensating. But you can see now to get 1.5 feet per second on 660 feet, I need 18 pounds of pressure, even with the larger tubing to achieve that. And with that, I'm going to need even more water than the original 1.4 because it's a larger diameter pipe segment. So again, it's kind of a compounding problem.
Yeah, so I was looking at that time to last emitter, 38 minutes, right? That's kind of shows you how slow things are flowing.
They can be, especially in an operating condition. So probably one of the things that I get asked the most though is how often should I flush? And it's hard for me to answer because again, I have to know, well, how are you flushing and are you doing the right duration? And then that is a result of the correct velocity. So if you're doing all of those things, still each system type, water quality is really going to dictate what we do on a flushing schedule protocol. There's some guidelines, but each field again is going to be different. For the sake of the audience and giving some advice, again, this is just very general advice. Orchard systems should be flushed bi-monthly. Drip tape systems, which are generally smaller size orifices and flow rates, should be flushed monthly. If surface water is used, I usually just increase their frequency by 2. So again, orchards would then be monthly, and then drip tape would actually be bi-weekly at this point. I know some growers on the west side that do that, but they realize, again, the cost of that one emitter being plugged and then it becoming 10 emitters, and then how many days was it plugged? They know the value of that crop. We're talking about the highest value processing tomato crop coming into this next year. They think about these things ahead of time. And then obviously another, I'll say, wild card in it is water treatment. It's going to play a large role in your flushing protocols. Because if you're helping eliminate, I'll say, external factors or things like bicarbonates, chemical precipitants, organic matter from affecting that inorganic matter, your sand, silt, clays from building up, you're going to be that much farther ahead. So continuous treatment, I think, plays a really big role. and something that growers should look at, especially on large scale systems, to help, again, make your flushing more effective, and then hopefully not even have to do it as often.
Yeah, well, it's establishing the process and then committing to the process. Easier said than done, but wow,
It's like going to the gym.
tremendous time and money savings if you can do it.
100%. And then another thing that, when we talk about products, I think it kind of gets overlooked on the flushing side. That I've done a whole webinar on air vents, which you talk about being one of the most popular webinars that we've done. Still surprising, but also I think it's important because, again, it's a product that maybe doesn't get enough attention from experts and manufacturers. But air is a major issue in irrigation systems, both from a performance and a reliability standpoint. Air vents play a large role in flushing also. If airlock occurs inside the system, flow can't move through it, and it can give you some really interesting results from a flow perspective. Pressures can damage your pipe segments. Air also not being able to get out of the system before, I'll say, it pressurizes or starts to seal, takes up space inside the pipe. And so now you're affecting the flow rate through that pipe segment, even if it's not completely airlocked. And then can affect those flows and some of the efficacies that we're talking about. I was flushing a system the other day, just looking at some stuff, and I mean, there were whole bubbles of air that were coming out of the ends of the line that you could literally see it in the water in suspension, and then once it kind of hit atmosphere, it would break apart. But it lives, and it's very real inside the system. And then again, as always, make sure those air vents are sized properly, placed in the proper location, and then also maintained, because we talk about the flushing of the system. Sometimes the PVC shavings and the wood chips and the dirt and all that stuff get stuck up in there. It doesn't allow the chamber to close, and then they leak or actually don't work at all. And so kind of in summary, I think if we went back through and looked at it, again, make sure the irrigation system is capable of handling those larger flows that we talked about, because flushing is going to require more flow than normal operating conditions. Make sure the design is created with products to make flushing easier, make it easier on yourself, make it easier on your employees. Again, it's going to pay for itself, and everybody's going to be a lot happier having to do it. Have valves installed to isolate acreages. Consider automation as part of this layout process that we're talking about. And then when we're talking about flushing, it's velocity, duration, and frequency. If you don't have the velocity, well, you're going to have to do it longer, and you're probably going to have to do it more often. So make sure we get the velocity. That's going to dictate the duration of the flush itself. And then again, probably lead to how often you're going to have to do it anyways from a frequency standpoint. Again, ask for the products that make it easier, and don't overlook air vents as part of your irrigation system and its performance.
So, wow, great summary, Corey. And yeah, that was really a generous amount of information you gave. Now, one thing I always learn, right, is think ahead, what's going to happen down the road. But oftentimes, if I haven't done this before, it's hard to think ahead, right? Because experience is really valuable. So I see you have your contact information here. If I'm watching this and I'm thinking and trying to think ahead, but I'm struggling a little bit or just want some help, is it okay for people to reach out to you and ask you for information?
Absolutely. That's what we're here for. We provide products, but also solutions. And people always say that. And I like to provide that intellectual property. You talk about those experiences, and I get to drive a lot. I get to walk a lot, and I get to see a lot of irrigation systems across the valley, and learn what works, what doesn't work, and anything I can do to share that with people, I think adds value.
Yeah, well, and that is huge, right? That's a huge offer, and I hope that people will take you up on it. So then somebody's making a comment here about reviewing screen debris buildup would prove valuable in establishing a flushing schedule. What do you think about that, Corey?
Yeah, I think that, obviously, when you look at the water quality, I think that goes back to that standpoint. Knowing how much debris you're collecting and how quickly is obviously going to play a role in everything that I just discussed. We have systems out there that have the screens inside our Power Lock swivel tees. We have a lot of systems that don't. But understanding kind of what those elements are capturing, I think would be, important, because again, if I'm realizing that there's degradation in the flow through those screens, maybe every 10 days of irrigation, or however many hours of operation, I should say, well, that would probably dictate how often I do it, because it goes back to the first emitter that we showed that was, kind of filmed over, that you were asking about. What was my opportunity cost for that emitter being plugged? How long was it plugged for? What can I do? What's my payback of getting ahead of that? So yeah, I think that collecting that information is really, really relevant in your field. And that's why, early on, I tried to say every field is very specific. Every water source is very specific. I have an orchard that I manage, and I can tell you that for whatever reason, row 16 always seems to be the one that gets the debris first.
Yeah.
I can't tell you why. It doesn't even really make sense hydrologically, but it happens. And so again, from experience, I know this is the road that once I start to see an issue there, okay, that's my trigger to make sure I get everything else taken care of.
Right, right. So interesting. Row 16. That sounds like a title to a book or something. But
that might be my new song.
So we've got another question coming in, and that is any recommendations on water treatments, or where we can get the best recommendations for our water sources?
Yeah, I mean, great question. Obviously, number one, as I've always said, find somebody certified, find a group of people that have experience. There's a lot of good companies. There's actually a gentleman inside of our company, Colin Scholl. He represents the irrigation surfactant line that we've been working on with Precision Labs. His background is really high end in water treatment, all the way from food processors down to the ag level. So reaching out to me and getting you in touch with Colin would be probably one of the first things I would do, because even for me, he's the guy that I'm like, hey, from a chemistry side, what should we be doing? How should we be doing it? Because he's a great resource.
Yeah, that is. And right, when you start thinking about the chemistry involved, that going to somebody who's just specializes in that is great.
Absolutely.
Yeah. So, well, Corey, thank you again for a great webinar. I really appreciate it. And for those of you who haven't seen Corey's other videos, especially on flushing and air vents, you can find those at janesusa.com/training, as well as all of our other training videos. Or if you like to listen to a podcast, we've got them wherever you listen to your favorite podcast too. So again, thank you very much. We really appreciate it, Corey. We thank all of our viewers. We know you guys are busy, especially this time of year. So spending a little time of your day with us, we really appreciate it. We'll be back on Friday talking with Danny Martinez about a few adjustments you can make to your irrigation system that are going to make a big difference in the water you use instantaneously. And by the way, most of these adjustments don't require the purchase of any equipment. So should be a good one. Thank you again. Thanks to everybody. We'll see you guys Friday. Thanks, Corey.
Thank you.